Okay, we are continuing in section 14.3, and the second half of the lecture deals with being able to verify trig identities. So the goal of using trig identities is to be able to manipulate uh, one side of the equal sign and get it to the other side. There's a variety of ways to solve this. The most common way is to pick one side of the equal sign and solve for it, and then verify that it looks like the other side. So for example A, for instance, we have secant squared theta minus 1 over secant squared theta, which is going to end up equaling sine squared theta. So what I want to do is I'm going to pay attention to the left-hand side of the equal sign in order to solve the problem. So if you look in your notes from page 1, I identify that secant squared theta ends up being tangent squared theta plus 1. So I'm going to write that down. So I'm going to have tangent squared theta plus 1 minus 1 all over secant squared theta. Now the 1 minus 1 ends up being 0, so now I'm just left with tangent squared theta over secant squared theta. So from here, I know that tangent squared theta can be rewritten as sine squared theta divided by cosine squared theta, and it's divided by secant squared theta, which can be rewritten as 1 over cosine squared theta. So when I divide a fraction, what I'm going to do is I'm going to take sine squared theta divided by cosine squared theta, and I'm going to multiply it by its reciprocal, which is cosine squared theta, over 1. And then I just cancel out my 2 cosine squared theta, and I'm left with sine squared theta, which is what is on the other side of our equal sign. If we look at B, I have secant theta minus cosine theta, and I want that to equal sine theta multiplied by tangent theta. So the first thing I'm going to do is I'm going to look at secant theta, and I can rewrite this as 1 over cosine theta minus cosine theta. I want to combine those two expressions, so I need to find a least common denominator. And the least common denominator in this case is cosine theta. So I'm going to say put cosine theta in both of our denominators. The first fraction, I didn't do anything to the denominator, so I can leave that as 1. But the other one, I multiplied a cosine theta to the denominator, so I must do the same thing to the numerator, so I'm left with cosine squared theta. Now I can combine them. So now I have 1 minus cosine squared theta divided by cosine theta. And from the notes, 1 minus cosine squared theta will end up being sine squared theta over cosine theta. And I can rewrite this top numerator as sine theta multiplied by sine theta over cosine theta. I know that sine over cosine is going to give me tangent, so I can rewrite this now as sine theta multiplied by tangent theta, which happens to be the other side of the equal sign. Okay? For C, I'm going to try to rewrite this into everything into cosine and sine properties. So secant x is going to give me 1 over cosine x, plus tangent x is going to be sine x over cosine x. In this case, we have a common denominator, cosine, so I can combine these. So it goes 1 plus the sine of x all over cosine x. Now, when we look in our notes, 1 has many different characteristics, one of which is sine squared theta plus cosine squared theta. So I'm going to rewrite one as sine squared x plus cosine squared x plus sine x all over cosine x. And since I'm dealing with, I already have a sine here, but now I need to get, I need to remove my cosine here. So it's going to be, oh, this is the one where this one should have been plus. I'm so sorry. So I already had it done. So for D, apologize for C, is I want to get sine theta multiplied by tan theta plus cotangent theta. I want it to be secant theta. So what I'm going to do first is I'm going to get everything in sine and cosine on the left-hand side. So I got sine theta multiplied by sine over cosine theta plus cosine theta over sine theta. So when I distribute this one here becomes sine squared theta over cosine theta plus the sines cancel, so I'm just left with cosine theta in the top. If I combine these terms, I need to find a common denominator, so I'm going to have cosine theta plus cosine theta. So I'm left with sine squared theta here, and I'm left with cosine squared theta here. Now I can say sine squared theta plus cosine squared theta all over cosine theta. Well, sine squared theta plus cosine squared theta gives me 1, so I get 1 over cosine theta, and 1 over cosine gives me secant theta, which is our top, our right-hand side of the equal sign. And that is being able to verify trig identities. Hope this helps. Till next time.